Hello friends, welcome in the new video. In this video, I will demonstrate you how to develop water quality data logger with SD card. So this is the continuation part of our last video. So this is the last setup which I have demonstrated you. So in this setup, I've used turbidity sensor and this TDS sensor, and we have interfaced both with the STM32, and also we have connected LCD. So on LCD, we have observed the reading of TDS and turbidity value, along with the indication whether the water is having excellent condition, good condition, poor or bad, right? So this is what we have already done in last video. Now in today's video, I'm just going to add one another module called SD card, and we will set up data logger system. So basically, what is data logger? So a data logger. So first of all, for this, I'm just going to add this library called FATFS. So I will just enable this in my STM Cube IDE. So this allow us to access the SD card or USB storage device, and using this, our STM32 controller can able to access the files and folder from the this type of storage devices. Okay. So first of all, what is data logger? So data logger is a device that record data over time. So imagine that we want to measure the water quality, but imagine that we want to observe this it every 10 seconds. You must observe some boards, right? Some advertisement type of boards are located in particular city, which continuously show the AQI, right? Air quality index. So that is real time data that continuously monitor. So imagine that you have to develop such system for water. So for particular pond or particular river, where you want continuous observation, right? So in that type of device, if you do not have logger, so you have to record this continuously, right? One thing is you can simply display on board, and second is you can record it. So that data logger will do the same thing, right? Because you can't remember what reading was 5 minutes ago or yesterday. So data logger solves the system that automatically saves sensor reading to storage. And some example, like weather station, fitness tracker, car black box, right? So these all are having this type of facility or continuous data records over the time, and you can access whenever it required, right? Now, so our project overview is like STM will read the sensors data. This part we have already completed. It saves the data into SD card, and along with this, it also shows on LCD. So this LCD part is also we have already covered, but this is the new thing that I'm going to demonstrate you in this video. And then later on, I will remove the SD card and connect this SD card with my PC and shows you this CSV file. So CSV file will having all the readings, right? So what is SD card? First of all, it is very popular thing. I will just no need to explain you this, but for the so just for knowledge purpose, SD means secure digital. Some cards you can see SD mini and micro card, right? And here you can simply plug and play this. So it's like a plug and play device, that it works with any computer. You have to simply uh, connect this with your system, right? And you can save the data. Different capacities are available, different types like micro SD. It's a tiny version of SD card. Then you have SDHC. It's for high capacity. So it provides storage up to 4 GB to 32 GB. Then we have also SDXC. It's called extended capacity, where you have more large storage like 32 GB to 2 TB terabyte, right? And speed is also having different variation like class 4, 10, ultra high speed, all. And file system, we are going to use FAT32. It's a file system, how the file will store in this. So because we are using this FATF FS library, so we will follow this FAT32. So initially I have formatted my SD card by keeping this file system, okay? And that SD card is available with me. I'm just simply going to plug it in the setup, and then I will show you the output, right? So this is what the SD card is all about. Now SD card, again, this to access the SD card, we have used this SPI communication. So I will show you how SD card is connected with the device, and I would also put the circuit diagram in the description of this video, so you can access this, because now our circuit become more and more complex. We have turbidity sensor, TDS sensor, LCD, and one another module called SD card module also there, right? SD card is having actually 4 wire, 3 for SPI, 1 for chip select, and power supply and ground. So our system become more and more complex. So that's why circuit diagram is important, so that you can follow this and you can develop the same system at your end. So basically, SPI communication is having 4 wire: master output, slave input, master input, slave output, clock, and CS. So I already explained you this SPI in detail in my previous videos, so I will not repeat it. I will put some link of some videos in this description. But for today's this demo, just understand like we are using master slave connection, and our microcontroller will be master. So our controller will initiate the communication. So ideally what happens, master provide the clock, along with it send the data to specific device, and the receiver will follow that clock and receive the data. Chip select pin is basically used to select the specific device, right? So this is what the overall SPI communication is, and we will use this. Now what is FATFS library? Okay, so simply understand like FATFS is a library to handle SD card file system, right? And with this library, it provides some functions which we can directly use in our program. So to mount the SD card, we can simply use F underscore mount. So it will allow us to mount the file system. Then to open the file, so these all are file operation, right? You have to remember this all are file operation. So to open the file, you have to simply use this F underscore open file name, and it will open the file. To write something, you have to use F print F, right? So this is how you can write this. And yes, one more thing, that this close, after reading every file, you must close this, otherwise you will not observe anything in this storage system, right? So you have to remember this thing. You must close the file and then remove the card. So during this development of this, I have observed many times that if I miss this file's close function, so simply when I connect the SD card, I found zero data write on the card. So this is what the idea is. You have to close the file, right? This is most important thing. Okay, so it's like a pointer on this n% of FF, it's called pointer to file system, right? It's one means mount immediate, this is the drive number, this double quote. Empty string means we are just telling that it's drive okay, and after executing this function it will return. So if it return fr okay, it means success. This no file system means SD card not formatted, or disk error, so hardware is not present or SD card is not present. Same way this open, to open the existing file or create a new. If this file is not present, it will create new file system, right? So these all are file operations that we are going to use it in our code. Okay, then RTC, so I already explained you this. I am just using this RTC to keep the track of the time. Even means we are not using this function that keep the track of time even power off, because for that I have to connect external battery with RTC. But we are using this to keep the track of the time, like yeah, we are just trying to record the data at every 2 seconds. So as a data logger, to keep the interval of 2 seconds, I'm using real-time clock, right? So I have already explained you all this, so I'm not repeating myself again in this video. This TDS sensor is also, I have explained you in last videos. You can see last 2 to 3 videos. We have already covered this all thing in detail, right? So TDS sensor basically measure the TDS, the turbidity measure the how cloudiness the water is, right? And now this data logger function. So this is the main core part of today's video. So I have added one water quality data logger function, and this in this function what I'm just trying to do, I'm just mounting the SD card, read the sensor, write data into CSV, and at the same time I will also update the same on LCD, right? So this is the overall end-to-end process. Now this is the configuration file for this FATFS library. So for now I'm just starting the code, and in today's video we have number of codes. So I will not write each and everything. I will show you how you can download, how you can use it, and I will explain you the main core part of the video, right, which is data logger. So for that we need some header files, some save files which are already written, okay? And for that I will put this code links in the description, so you can download it. So here is the project. It's called STM32 data quality water quality data logger, right? Here you can see we have used STM cube ID to generate this code. So this is our original code, right? In last video I have explained you this code. So this code basically uh, read two sensors value. One is TDS sensor and one is turbidity sensor, and it displays the same on LCD. Okay, so up to here we have already understood, right? Now in today's video I'm just adding data logger. So for that you have to add different header files. So first of all, let us open the core part. You have to remember this part core and INC, and here in INC you have to use this sd underscore spi.h header file, right? This is the header file which contain all SD card commands. So these are the commands. So basically commands means you have to write this command so SD card will understand what we are trying to do. So if we will write 0 to SD card, it means we are telling SD card to go in idle state, right? If we will write 24 to SD card, it means we are telling SD card that we are going to write the block, right? Same way we have different commands, read OCR, right? write multiple block. All these commands are there. Along with this, some functions are also there. So we are going to define this function in C file, sd init, sd read block, sd write block, and we are going to use this also, right? So let us add this header file first of all. So you have to simply create one header file. So in main, you have to open file, you have to create this file with same name and copy the content, right, as it is. Now another function, this is sd disk io, right? So this is for the sd write, how to write in this card, how to handle different multiple functionality. This again, this is related to our sd card, right? So I have to add this c file also, because this code required multiple trial and error type of thing, right? So I cannot explain you in one go, otherwise this video will become 1.5 hour or 2 hours long duration, right? So this is another function. This is another third file is sd spi. So this is related to spi, right? So here we are using all the spi related things, how we will access this. So as I told you earlier, this is spi send, this is sd send command, right? Sd init, how to initialize this. So basically we are just dealing with the spi port, right? And how we can access this thing. So all things are written over here. You can see sd write block, how to write the block to sd card, right? Then we have also this sd read block, right? So all things. So let us just create this file first of all. Again in src, in inc we have to write header file, in src we have to write this c file. Okay, so now I have added all these required three files. You have to remember sd spi.h, sd disk io.c, sd spi.c, right? We have to simply add these three header file simply, right? Now one more thing, as per the connections, this I already explained you, right? As per the connections, I'm using this SPI interface to connect my SD card, right? So for that, we have to simply open this IOC file and we have to enable the SPI as well, right? So I just copy the code, but now I will enable the SPI. So for that, go to the connectivity, SPI, simply full duplex, right? So here you can see it will enable this three line, SPI one clock, SPI one MISO, and MOSI, master in slave output, master output slave in. These three pins it will enable, and along with this full duplex mode, I will simply set data side is equal to 8 bit and prescaler is equal to 64 to reduce the speed. Okay, this is what the configuration of SPI. So now I will connect my SD card with this 3 pin only. Okay, and as I told you earlier, I will put the circuit diagram in the description of this video, so you can simply access that. Now we also have chip select, so I'm just going to enable this PD14 as a chip select. So for chip select, you have to simply write high or low on pin, so that's why you have to configure it as GPI output, right? And now you have to simply give the name, because in this code, as per this code, this pin should change to this name, sd underscore cs. That's if you have to simply give the name. So for that, you have to check the system code GPIO PD14, and here you have to simply give the name, user label. Okay, and see maximum output speed, let us set it to very high. Okay, so we can have this chip select at high frequency. And after initializing this SPI and all, let us open this middleware software, and here you have to check this FATFS, and this FATFS you have to simply click user select button, right? So this you have to enable this, then you can access the functionality of FATFS in your code. So simply open the simply enable this, and then let's generate the code. Okay, let us generate the code. So it will generate the code for us, and here you can see it will add all required thing. Our original file will not change, however our main.c file will change, so that's why I have to simply change overall this code. But here you can see we have this FATFS, we have the target, we have this configuration file which I'm just talking about, right? So you have to enable multiple things over here. Okay, and now main.c. So I'm just copying my this main.c file over here and just overwriting this. So here you can see all the required things are already enabled over here, right? ADC, I2C, SPI, right? All required functions are written over here. So in our original code, the required data logger part is added in this function, so we can simply override this. Okay, it is simply safer to directly write whole functions as it is in this main.c file. So I'm just selecting, removing, and copying, overwriting this. Okay, so I have completed all the required steps. Let us simply generate the, or let us simply debug the code and check whether any error is there or not. And if error is not there, okay, then we can simply generate the release or simply generate the hex file. Now here all the things are same as it is. The only different part is in while one loop I have before while one loop I have added this water quality data logger function. So this is one time this function will call, and what this function will do, here you can see I have simply label it as a data logger version 3.0, right? Because 1.0 was simply TDS, it was our water quality meter, then TDS plus turbidity, and now this is with data logger. So I just given this name. Okay, and now this is our main functions which we are just calling only single time. So let me explain you this function. So here simply you can see this all thing will display. Okay, now here this is LCD command. So on LCD what you will see, so on LCD you will first, I am just clearing the LCD. On first line I'm just writing water logger starting, right? On then we are just mounting the SD card. So to mount the SD card, what we are doing, we have to simply send the command LCD command 01. So we are actually sending this command on LCD, and again this 01 will clear the LCD. Then this is on first line, this function will write mount SD card. Okay, now what this function will check, it will simply check whether the SD card is mount or not. If SD card mount return will not equal to 0, it means that SD card mount fail, right? So if your card is not present or if a device is not accessible, so this will return uh, not equal to 0. And simply using this loop only, we can have this checking that SD card is mounting is fail, and it will simply display SD fail. So our data logger will not go further, right? Because simply SD card is not present, so nothing will work. So again, this is just we are checking this function and we are displaying on LCD only, right? Now this next part is if SD card mount is okay, right? Because here we are simply mounting the SD card. Then on LCD you will see SD okay. SD okay means now we can write anything. So this function will go into second step. Second step is creating CSV file. So I'm just giving name of the file log.csv, right? Here's the log.csv is the file which will going to create in SD card. Okay. Now this function again will write the file name. Here we are giving file name and header. Header means this will be the first line of the CSV file. So if you know about the CSV file, the CSV is having different column, right? And if each column is having some values, so it's a comma separated file. That's why it's called CSV. And this is the header. So we have sample, TDS, turbidity, quality, and time. Time means it's a real time clock's timing, which is again random. We are giving. We are not setting actual time, actual date, but it will log something, right? I will show you. So this function will write the file, and if this function will fail, so we will have simply this display fail to create CSV file on UART. Okay, and we will call this SD unmount. So we will simply unmount the drive because we have already mounted it. So we have to unmount because this write file function fail means we are not able to, or microcontroller is not able to create the file, right? And if file creates, then we will enter into the next step, and the next step is logging 10 water quality samples. So it will simply log 10 different water quality sample, and it will start display this on LCD logging data, right? So once it will start displaying this logging data, this loop will execute 10 times. And for each time you can see it is just reading the current time. And as I told you earlier, with RTC get time, you have to use this function RTC get data. Otherwise, you will not get anything in this function, right? And we are just simply measuring or simply reading this TDS value, turbidity value using this function. These functions we have already explained. I have explained you, right? And it will convert this into required format, right? And this get water quality is another function which you can see over here. It is just to display the water quality is bad or good or fair, right? And this is separately written function. One time it will execute, and this is to log this thing, right? Because here you can see in header we have this quality. So this is the quality, right? So again, this will simply check the quality. So here we have the quality, we have the time, right? And it will also display on LCD. Okay, it will display on LCD this sample number, TDS value, turbidity value, right? It will continuously display. and it will format the time string also, current hour, current minute, current second, and it will write all these things in our CSV file, right? So it will simply, here you can see it will simply copy this into CSV buffer. So this is the buffer for each reading, and for each reading it will append this with the file, our file, right? It will actually write this thing in our file, and if this will fail, so it will display this message, fail to write sample on this. Okay, and if it will successfully complete this, so this will continuously repeat for 10 times, and after 10 it will display all 10 sample logged successfully. And now logging is done, 10 sample saved, and you can remove the card and you can check. So this is simply message display on UART, right? File on SD card. So you can simply, now after that we are also, what we are doing, we are simply listing the file, we are unmounting the SD card, because as I told you earlier, we have to open the file, you have to close the file, we have to unmount the card, and now it will display this message, data logging complete, remove SD card and check this log file, right? So this is the last step, and after that you can remove the SD card and check the file. So this is what the overall function is. Now let us release the target, and I'm just going to load this on my board. So meanwhile, I'm just going to show you the connections also. This is the UART. So here is the connection. You can see this is the circuit, this is the board. Yet these two sensors we have already explained. I have explained you in last videos. This is the cloudy water with termite, and this is the clean water. And this is our SD card module. You can see SD card module is connected with this. So this is PA5, PA6, PA7 pin. One is for chip select. I have powered this 5 volt. Okay, same 5 volt is connected with this also, and yes, same 5 volt is connected with this LCD also, and this is the card, this is the SD card. I'm just inserting this SD card in this. Yes, and you can see card is connected. Overall you can see the things, right? And let us upload the code. And now observe this L3D as well as this UART also. So you can see water quality. Here you can see the message SD card storage mount successfully. Now it start recording this. This is for clean water. You can see second reading, third reading. Now let us move this sensor from clean water to dirty water. Here you can see the reading, right? And 10 sample completed. So I just, for this video, I just recorded 10 samples only. And now data logger is completed. From this video you can see now it is now safely, we can remove this card, because here you can see the message unmount SD card. SD card is already unmounted. So I'm just removing this card. I'm just connecting this with the card reader. I'm removing my board, and I'm just connecting this with the laptop. And here you can see the log file. And here you can see the reading. So for 10 different trading, you can see initially 8 samples were good because that was clean water. And then when I inserted this sensor into the dirty water, you can see it shows 10 bad reading, right? Two readings having higher turbidity, right? And that is what you can see from this CSV file. So this is simply for 10 readings, but we can also write the code to record the data for whole day. And at the midnight 12, we can simply send this file using IoT over the internet, and then on the next second 12:01 we can format the SD card and again start new logging for new day. So that is also possible. And in fact we have the SD card is having huge amount, right? 32 GB, 60 GB, so you can log data for month or even for years also, right? So this is what the data logger system is. If you like my video, please subscribe my YouTube channels, like my video, share it with your friends. And in next video, I will add one more pH sensor, and ultimately we will going to build a complete water quality system which measure the different readings and which log the data. So this is for this video. Thanks for watching. Thanks a lot.